Welcome. Excuse me, with a little cough in the mornings when I do these things. But in this video, I'm going to do a little review of Cisco iOS and also IPv4 static routes. Okay, so as you can see here, we have a network with 3 routers, and this is all just IPv4 in this case. And what I have done is I have already configured routers R2 and R3 with all their information, and also the PC over here, 192.168.4.50. So we'll look at their information in a moment, but let's go ahead and configure router R1. So it comes up here. And we can see it says, would you like to enter initial configuration dialog? No. Okay. That's been there for, gosh, as long as I've been doing this for 30 plus years. So I'm going to hit enter to continue here. That is actually a little menu, it prompts you along for configuration. No one ever uses it. I've never known anybody to ever use it. Yet it's still in Cisco iOS for whatever reason. Okay, so what we're going to do first is I'm in a user mode. So to do any configuration, remember I have to go into privilege mode, the enable command. All right. Next, what I'm going to do is do global configuration mode, config T. And I'm going to name the host name router 1. And actually the very next command I like to do is no IP domain. And remember, I can always do tab for autocomplete if I want to do that, or I can just shorten it as long as the command or parameter is unique. Okay, so remember what that does is to make sure if I fat finger something, it doesn't think that I'm trying to search for a telnet or SSH into a device, and it starts to do it looking for a DNS server, and it just takes like 2 minutes for it to get out of that. So that's what that helps us with. Next, I'm going to go into line console 0, and what I'm going to do first is logging synchronous. That's so if I have any output from the operating system and I'm in the middle of typing a command, it gives me a new prompt and leaves me off with wherever I was on my command. Next, what I'm going to do is, this is only a lab only command, but I'm going to say exec timeout 0 space 0. I mean, don't time me out. All right. And we only do that in the lab environment because we want to, if we're not at that device and we walk away, we want it to time out and ask for a password for somebody's going to try to access it. So let's do that. Password, this would be the console password. Okay, so there's our line console 0. I'm going to do exit here. Next, I'm going to do line VTY 0 space 4. And right now, I'm just going to do transport input telnet. Again, this is only for a lab environment. In production environment, you'd want to use SSH. That way, the password and all the information sent between the device that is remotely connected to this router would be encrypted. Telnet, everything's sent in plain text. Okay. Again, I'm going to do password Cisco in case we want to log in via telnet. All right, I'm going to do exit here. All right, so next what I want to do is I'm going to configure the gig 000 interface to be a member of the 192.168.1.0 network. And I'm going to give it the .1 address. Okay, so I'm going to say interface, and I can just abbreviate that like enter. G, and I can type out gigabit Ethernet if I wanted to, like that. But I can just do a G if I want. 0/0/0. Okay, I'm going to say IP address 192.168.1.1, and we got to give the mask. So this is the host address. So it's a host, that's its host address on this network. Okay, and then we'll do, now watch when I do no shutdown here. So notice that this is red here, this link light, and same on this side. They are red, that's because the interface is shut down. That is why the switch, its link light is also, well, wouldn't normally be red, it'd just be off. You wouldn't see a link light. But as soon as I do no shutdown here and this interface comes up, then the switch port here sees a carrier signal and will also come up. But you will see, actually, it won't go green right away. Let's see what color it goes. Amber. Anybody remember why amber? What is a switch going through? If you've taken CIS 82 or CCNA 2 class, you'll know what it's going through is the spanning tree protocol. Make sure there's no loops here. So it will take about 50 seconds, and then it'll eventually turn green because we don't have any loops here in the Ethernet LAN. Okay, but you can see the router's interface came up green. Okay. All right, there we go. So now it came up green as well on the switch. Let's go over to, let me type exit here, and I'm going to type interface gigabit. I'll just do G001, and I'm going to do IP address, and I just shorten address to add, 192.168.2.1. Okay, that's its IP address, 255.255.255.0. And I will do a no shutdown on this one as well. I'll just do no shut. Oh, what's it complaining about here? Duplicate address detected. Did I make a typo or something? Oh, I must have a, oh, love it when I make mistakes. It's saying duplicate address detected. What's wrong? I gave it 2.1. Isn't that the right address? No, Rick. This router has 2.1 on it. So it says you can't have the same IP address on this network. I meant to make that not 2.1, but 2.2. So it's always good to first remove that IP address. So I'm going to hit the up arrow. I'm going to do no IP address. That's how you always remove any command in Cisco iOS, is you typically put no in front of it. All right, there we go. And then what I'll do is I'll change that to 2.2. There we go, no complaints there. Okay. All right, even gave me some information. You can see where it says duplicate address here, right? Even gave me some information, says, hey, whoever has MAC address, this MAC address, and that's the MAC address on this Ethernet interface, there's a duplicate. So go out and find that device and either change that one or change yours. Okay, but it looks like we're good now. And notice that it came up green because we're both now have our in the no shutdown state. This is a crossover cable between these two directly connected routers. This is a straight through cable connected between unlike devices, a switch and a router. Okay, so we have our router configured. I'm going to do end here, and I'm going to do copy, run to start. And you know what's always a good idea? Save as you go. So I'm going to do file save as, and I'm going to put my last name on the end of this. There we go. Make sure I save it. Okay. All right, so we have router 1 going. Okay, now what should we be able to do from router 1? Well, let me move this over here. Can I ping the PC? Well, actually, I haven't configured the PC's interface. So let's go ahead and do that first. Okay, so let's configure the PC. Something came up there. There we go. So I'm going to configure, go over here, and I'll go fast Ethernet 0. I'm going to do a static address, 192.168.1.100. Oh, almost. Rick, you and your typos this morning. There we go. I'm going to click on subnet mask and it'll default to what used to be a classful mask. We don't do classful addressing anymore, but that is the mask we want, 255, 255, 255.0. One more thing I need to do, I'm going to go up to settings here, and I need to set the default gateway address, the IP address of this router, 192.168.1.1. All right, so we should be all set. Okay. Let me go ahead and test, make sure everything's working here. Desktop, I'm going to do command prompt. Let me see if I can, first I'll do IP config. There's my IP address, default gateway. Oh, I see they did some things for me. Okay, I'll have to do some testing. I'm looking at the IPv6 information. I've been working with the packet tracer team. As you know, I do a little for Cisco systems, and making sure that the IPv6 stuff is correct. So that's good to see that they're updating this. I'm using version 7.3. All right, enough of IPv6 for now. Let's go see if we can ping the default gateway. Well, that means I can connect to my network, and even better, I can connect to my default gateway. So any packets that are outside my network are going to the default gateway. Excellent. Okay. Can I ping this IP address here? Let's see. Ping 192.168.4.50. Can I ping this PC over here? What do you think? The answer is no. Okay, why is that? All right, well, we haven't configured the routers to do any sort of routing. The only thing that these routers know about, let's take a look here. The only thing that these routers know about is their own IP addressing information. So first of all, I'm going to do show IP interface brief. It's a great command because it shows you what the interfaces are on, the IP addresses are on these interfaces. Okay, I'm going to do a command show IP route. This is the IPv4 routing table. And look at R1. All it says, I only know about 2 networks. Okay, I know this, the C means I'm directly connected to this network here, which is this network right here. It says I'm directly connected to this 192.168.1.0 network. And I'm directly connected to this 192.168.2.0 network. That's because it has IP addresses that we configured on both those networks. But that's all it knows about. Just like this host here, this PC only knows about the 192.168.1.0 network because it has an IP address on that network. The difference is a router usually belongs to multiple networks. All right, well, let's take a look at some of these other routers here. I've already configured these. If I do show IP interface brief, okay, it has an IP address on the gig 000. It has an IP address on the 192.168.2.0 network. It's 2.1. And on the 192.168.3.0 network, it has a 3.1 address. Okay, so if I do show IP route, yes, I only know about 2 networks, my 2 directly connected networks. That's what the C means. It means it's directly connected to those networks. By the way, this L means this is the local interface address on that network. Now, it doesn't show the right subnet mask. It actually shows a what we call a host mask. It's showing the full 32 bits. We won't worry about that right now, but this is the IP address, and that would be its mask. But that's the address on that network that it has. Okay, but it does, R2, notice that R2 knows about the 192.168.2.0 network and the 192.168.3.0 network, but it doesn't know about the 192.168.1.0 or 4.0. Okay. And while I'm doing this, I'm going to bring up a little tool I like to use that my ink to go. All right. Yes, I want to move it to that screen. All right. So let's take a look at router R3. And you can see I did some pinging here just to do some testing. But let's do show IP interface brief.
And it's a member, it has an IP address 192.168.4.1 on this side and 192.168.3.2 on this side. Yes, and if I do show IP route, you'll see that it's a member of those two networks. Okay. All right, but getting back to this router here, it's a member of these two networks, right? So let me, so router R1 says, I know about this network and I know about this network. I have two directly connected networks, but I don't know about how to get to this network and I don't know how to get to this network. That requires routing. So what we're going to do is configure static routes. So this router knows how to get to this network and also knows how to get to this network. And what it's going to do is send those packets where? How will it reach these two networks? Well, what's the next hop router? Right here. Okay, so we're going to configure static routes showing this network and this network with this address as the next hop router. Okay, meaning any packets I have for those networks, I'll send to this router. That's really no difference than the default gateway on this host. Okay, if it's not on my network, this network here, it sends it to the next hop router. Okay, we'll call it the default gateway router. Okay, all right, so let's go ahead and configure some static routes. Okay, so very easy to do. Okay, I'm going to go into global configuration mode. I'm going to type IP route, so IP meaning IPv4 route, and then the next command I give is the remote network. Okay, 192.168.3.0 and its subnet mask. So anything in this network, 192.168.3.0, this network here, R1 is going to send it to where? Well, we're going to put the IP address of router R2 on this interface. It's got to be able to send it to the IP address on a network that they both belong to. Okay, so let's do this, 192.168.2.1. So it's going to send it, R1 is going to send it to this IP address. It says, here's the packet, it's all yours, you take care of it. Okay, but what if we want to send packets to 4.0? Well, we're going to send it to the same next hop router. So all I have to do is change this to a 4. 192.168.4.0. This remote network right here, and this is the next hop router, same next hop router. Okay, end. Okay, what if I do show IP route at this point? There's my two static routes. Okay, S for static. This is the remote network, and this is the next hop router. This here, 1 is the administrative distance, so I talk about that in another video. Okay, this just is the metric. There is no routing metric for static routes. All right, so does that mean I can reach those networks? Well, let's find out. This is exciting. Okay, so let me go back here. So now what? I should be able to ping 4.50, right? Because this router knows how to get to the 4.0 network, right? You can tell by the sound of my voice that I'm kind of being a little sarcastic here, but let's hit enter. Hey, this isn't looking good. Timeout. They're not getting in. The packets aren't getting there. Okay, you might have guessed, but let's let this time out and I'll talk about it. One more. You're trying. I know you're trying. There you go. All right, what's happening is, yeah, router R1 is sending the packets to R2, but what's happening is R2 goes 192.168.4.0. I don't know how to get there. That's not in my routing table. So it's dropping the packets. It's putting them in the bit bucket. Okay. Matter of fact, we can even see that. Okay. Let me actually go back here. Let's see if we can do a trace route. Trace RT 192.168.4.50. And you can see that it got to the default gateway, right? 1.1. Okay. Okay, but R2 is not replying. It says, I don't know how to get there. All right. We can also do a trace route from here. 192.168.4.50. It says, okay, I send them to 2.1, but that's router R2, but I'm not getting, they're not going any further. That's because R2 is dropping them. Okay. So let's go to R2. So again, remember, so nothing in its routing table about 4.0. So let's put that in there. So I'm going to do config T. Let's do IP route 192.168.4.0, this remote network right here. And 255.255.255.0. All right. And the next hop router, so this is R2. It wants to send them to R3. We need an interface, the next hop on the same network as R2, and that would be 192.168.3.2. So let's go there. 192.168.3.2. Great. Let's do show IP route. There's our static route. Now they should be getting there, right? All right. Let's take a look here. Oops, I'm going to do breakout of that. All right. So can I, let's just do a ping here. Is it working? This doesn't look good. Still not working. What's going on here? Let's do this trace route here now. Let's go back. Let's see, why can't I get to 4.50? Okay, packets are going to router 2. Let me see, that shouldn't be the exact error I'm getting. Let me see here, make sure I did this right. 3.2, showing a little odd. It should be showing one more thing. Okay. Let me make sure that I've got my IP addresses. By the way, it shouldn't be working, so that's a good thing. I just want to make sure I can ping 192.168.3.2. Yeah, okay, so that's here. Okay, so what's happening is this. Our PC says, I have a packet, this PC here, to send here. It is going to router R1. Okay. R1 looks in its IP. Let me get out of that. So I'm going to let a timeout here. There's actually a command Control-Shift-6 that'll break me out of it. But I'm in Packet Tracer and on my Mac, and sometimes it'll actually thinks I'm doing some other kind of command. So we'll just let that time out. But let me talk about what's happening here. R1 in its routing table says, yeah, I know how to get to 4.50. What I'm going to do is I'm going to send that packet here to R2. R2 says, yeah, I know how to get to this network because we did a static route, and it sends it here. R3 says, yeah, I know how to get to this IP address because it's on my network. Okay, so the packet is getting there. I said, well, wait a minute, Rick, but that ping is not succeeding, remember? Okay, we did the ping here and it didn't succeed. But you said the packet's getting there. And this is still, I think it's got one more. Okay, we'll just let it do things. So the packet's getting there. Now, what about this PC here? Okay, it knows. Let me go over here to desktop. command prompt. Does it know how to get to its default gateway? So I do IP config. It knows its default gateway, which is 4.1. Yes, and it can ping it. Let me do that. So it pings it. So what's happening is, that's okay. So it's saying, okay, I'm going to send the ping back. So I send it back to this router. And here's our problem. R3 says, yeah, I knew how to send the packet there, but hey, nobody told me. If I look at R3's routing table, is there anything that in here that tells me how to get to 1.0 network, how to send the packet back? No. We need static routes, not just for getting packets there, but also getting them back to the source of the packet. Okay. So we have to configure, so that's where our problem lies. Okay, let me break out of this. See, I don't know if you heard that click. I knew it was going to do that. No thanks. That's, yeah. See if I can break out of it. You are causing me problems here, packet tracer. All right. All right, so but we can deal with this. I'll deal with this here in a moment. Okay, it finally timed out on me. Sorry about that. You can see it finally went through all 30 tries. Okay, so the problem is we need static routes sending things back. So on router R3, I'm going to do config T here. I'm going to say IP route for the remote networks on this side. So I need to do the 2.0 and 1.0. 192.168 2.0. And I'm going to do 255, 255, 255, 0. And the next hop, so let me kind of get rid of some of this here. So the next hop is going to be router R2, this interface right here. So I'm on R3, we want to send all packets to any of the remote networks going this way on this side to 192.168.3.1. 192.168.3.1. So I'm also going to do the same thing for the 1.0 network. Okay, so R3 will now send those packets to R2, but R2 has the same problem, okay, as we had on R3. R2 only knows about this remote network over here, the 4.0. It doesn't know about how to get the packets back to 1.0. So we need to do that as well. So I'm going to actually do an up arrow. I should be, there it is. So I'm going to send these. I don't know why I bothered with that. I'm going to have to erase quite a few things. So let's do the 1.0, 192.168, 1.0. I'm on R2. And I'm going to do 255, 250, whoops. How do I spell 255? There we go. And the next hop will be 192.168, 2.1. So for R2, sending packets to 192.168, 1.0, this address is the next hop. For R2, sending packets to 4.0 network, this address is the next hop. So, okay, so what did I say here? The next hop, 192.168, 2.2. So let's do that. Okay. And let's do show IP route. There's my static route there, 1.0, and there's the 4.0. Two different next hop routes. Okay, one on the left, one on the right. Okay, so let's see how we're looking now. All right, let's see if we can ping. There we go. That looks better, doesn't it? If I do a trace RT, trace route 192.168.4.50. Okay, we can see there. So now it's showing me the every router along the way. First send it to 1.1, then 2.1, then 3.2, and then 4.50, the source. And then same thing. Then on the so 4.50 is able to send the packet back. And now router 3 says, yeah, I know where the source of that packet is, the new destination IP address, 192.168.1.100. So the packets coming back this way have the destination IP address 192.168.1.100. And we put a route in the routing tables for router 3 and router 2 on how to get to this network. Okay. One more thing I want to show you. And as you notice that these, let's do this on router R3. Notice that router R3, everything that is not on its network, anything out here, since it only has one interface, but we could have other, so we could actually have another router here that's connected to even another router here. But let's say the majority of the packets are going to be sent to this router here. We can actually make a default route. So we could have specific static routes going to this router and this router, and then say for everything else, send it to router R2. So let me show you how we do a default route. Okay. So the first thing I'm going to do is I'm going to go ahead and remove these networks that I just did on R3. I'm going to say no here. And there's the 1.0. I'm going to do a no there. So I'm going to remove both of those. Okay. And just to show you that they are removed, show IP route, they are gone. Okay. We can also do show running config. I'll show that in a moment to you. Okay, so now I'm going to do config T, okay, IP route, and to do a default route in IPv4 is quad 0, no IP address. And then this is how many bits must match. 0 bits must match for this to be a match. And I'm going to send all those packets. So if it's not in my routing table, I'm going to send them to 192.168. So we're router R3. I'm going to send them here to router R2, 192.168.3.1. Okay. Do show IP route. So look, this is my default route. So that means how many bits must match? 0. So if it doesn't have a better match, so here we have 24 bits that must match this network, match this one, means the destination IP address of the packet. It needs 24 bits to match this, to be part of, to match this address. It needs the first 24 bits to match this network, to use that interface. Other than that, if I don't have any other routes in here, 0 bits need to match. I'm sending all other packets to 3.1 right here. Okay, so let's make sure that's working. And let's do it from PC4 here. Command prompt. Let me go ahead and ping 192.168. Whoops, how do I spell 192 here? 192.168. 1.100. Okay, so I'm here at this PC here, and I want to ping this PC over here. And yes, everything's still working fine. I can even do a trace route like we did before. Trace RT in Windows, 192.168, 1.100. And you can see the next hops, 4.1, 3.1, 2.2, and then the destination, 1.100. And they know how to get back. Okay. So now we have complete routing information. By the way, I can always look at this information in my running configs. Oh, I meant to look at the running config here. Show, whoops, here we go. Show run. Okay, so we can see my configurations, and there's my 2 static routes here that I configured for this network and this network. All the remote networks I want to be able to get to are right there. If I look at this router here, I can do show IP route. We should just see our, oops, show run, sorry. We should just be able to see the default route, yeah. And it's always a good idea to remove anything that's no longer being used. Okay, so remember, we removed these static routes here that we had in there previously. We removed them with the no command first. Okay. All right, and just to make sure I'm saving everything, undo save. Save my packet tracer file. And one thing with saving packet tracer files, so let's do this first. Make sure copy, run, start. You got to make sure all your running configs are saved first. Copy, run, start. Copy, run, start. Okay, now I'm going to go up here and I'm going to save my packet tracer file. There we go. Okay, so next time I load the packet tracer file, I've got everything working. All right, I hope this helps you understand the static routing, IPv4 static routing. IPv6 is just identical, just different addressing. And remember, we need static routes are fine for small networks, but you can see if this was a more complex network, it's not scalable, not very scalable. It gets complicated to configure all these static routes. Also, the problem is if we had a router here, let's say these were connected and our static routes from R3 were going via R2, but let's say this link goes down, okay? It's not self-healing, meaning that R3 doesn't automatically know, hey, there's another way there. That's what we use dynamic routing protocols for. There's ways to do this with static routes, to have backups called floating static routes. And I have a video that talks a little bit about that you'll watch. But it's fine for small networks, but it can get very complicated for any kind of larger networks. So it's always better to use a dynamic routing protocol that would do this automatically. All right. All right, hope this helped. Enjoy, and I will be seeing you in later videos.